using throws. Error and runtime exception and their subclasses are called unchecked exceptions. Unchecked exceptions means that the Java compiler will not check for this kind of exceptions. If a method might throw and not catch a checked exception, such as IO exception, then it must declare that it throws that kind of exception by use of throws. Again, checked exceptions means that Java compiler will check for this kind of exceptions before compiling the program. So the general form for throws is within the method declaration, you'll have throws and a list of the exceptions. Let's look at this example. Here we have a method called myMethod which might throw arithmetic exception and null pointer exception. If any method wants to call myMethod needs to handle both arithmetic and null pointer exception. Here we have a main method and we put the myMethod call into the try and then we cache the arithmetic and null pointer exceptions. Just notice here that both arithmetic and null pointer exceptions are part of unchecked exceptions, which means that we did not have to use throws. However, a check exception such as IO exception, we must declare it in the method definition. So let's see some examples in the editor. So here we have a program where we prompt the user to enter a letter. We then read the letter with the system.in.read function and then assign the letter to the char ch, and then we will print the character on the screen. So the system.in.read function might throw an IO exception. So we either need to handle the exception here, or we can put throws into the main function declaration and then let Java runtime environment to handle that, which we did that part in the past. So in this example, I'm going to try to handle it myself by putting the ch system.in.read into a try block. So I can catch this type of exception with java.io exception, and let's put the object name as e. Then we can print something such as unexpected IO error. So just in case that the program doesn't give an error, so I'm going to, when I declare the ch, I'm going to assign, let's assign question mark character, just in case something goes wrong, we'll print the question mark. So we're ready to test this program. So I'm going to compile this and I'm going to run this. It's going to say enter a letter. I want to enter A, and then you enter A. So there's unlikely that we might run into an exception, but what we need to know that anytime we use system.in.read, we need to handle the exception. So another way to look at it is that we can have a method that will handle the user input, and then which might throw an exception and will handle it in the main method. So I'm going to define a function. So this method will handle the user input. So I'm going to take this from here. So again, I'm going to define ch. that is set to question mark initially. And if everything goes all right, I'm going to return the ch. But again, since we're using the system.in.read in this method, this method might throw in an exception, right? So we have to say throws java.io dot. Okay, so we know that this function might throw IO exception. However, that we don't want to handle it here. We want to make sure whichever method that calls this prompt should handle it. So in that case, I'm going to put this in here. I'm going to say ch is set to prompt, and I'll handle it and I'll move on. So again, in case something goes wrong here, I'm setting the ch to question mark. So let's test this again. So enter a letter, capital D, and then you enter D. So another way to look at it, maybe we don't want to handle it either in the main method. So in that case, we will make sure that we put this statement into the main method as well, and just not handle it in this case. Just remove this. And then in that case, if error happens, we know that Java runtime environment will handle it. In most likely, it will crash the program. So let's test this. Okay, let's add Z. So again, it's unlikely that we run into an exception, but if we do, we know how to handle it.